Greetings. My name is Will Bortin. Come with me as we journey into the classrooms. It takes a great mind to change the way we think. No one knew why things fell until Isaac Newton created Newton's laws. For years, people thought that light traveled as a wave, until Albert Einstein proposed that it could also travel as a particle. Before Richard Feynman, I don't know anything about Richard Feynman. This is the way with all geniuses. Every now and then, a person is born into the world who changes the course of science and history. Today we're going to talk about one such a man. One that taught me personally. And his name was Joseph Manildi.
April 22nd, 2006. Joseph Manildi is teaching basic physics to a crowded classroom. He is not having desirable results.
Why don't these kids get it?
He said.
It's just basic momentum. Why don't they see what I see?
Ever since Manildi was in high school, he had been a master of momentum, and of physics in general. Looking through his textbooks, he always understood more than his classmates ever could. Sitting there now at his desk in the crowded classroom, Mr. Manildi wondered. Then it struck him, like a lightning bolt in a thunderstorm. An idea he had buried in his subconscious long ago for fear of administrative repercussion. And thus, Manildi coined the unit, the Manildi.
Momentum is the measure of the strength of a movement. If force measures strength with acceleration, momentum measures strength with velocity. That's why if you are hit with a small feather coming at you with a certain velocity, you won't feel it as much as, say, an oncoming truck hitting you with that same amount of velocity. Momentum, that is because the truck has more momentum. Momentum is given by the equation P, or momentum, is equal to mass times velocity. So therefore, the strength of something that is moving at a speed is proportional to its mass, and that explains the difference between a feather and an oncoming truck. And furthermore, momentum is conserved. So if two trains collide, before and after they collide, the total momentum of the system is constant. And that's given by the equation, the conservation of momentum, which is mass times velocity initial equals the mass times velocity of the final. And momentum is given by the unit kilograms of meters per second.
Quite right. The simple equation for momentum is P equals mv, or mass times velocity. However, when you multiply these two variables, the units become near unintelligible. Here, I'll show them to you, but don't be disappointed if you find yourself at a complete loss. You see? I don't know about you, but if I were a physics expert, which I am by the way, look at my graduation photo. There it is. I would be looking for alternative ways to describe this unit. Let's take a look at what actual physics students have to say about the unit kilogram meters per second.
When the Great Recession hit, I lost everything. my home, my wife, my kids, everything. And most importantly, I lost my unit book. How am I supposed to do physics now if we're using kilogram meters per second and I don't have my unit book?
Die Einheit pro Kilogramm pro Meter pro Sekunde garantiert mein Leben. Es ist ganz schlecht. Ja, das ist, ja, ich verdiene mehr als das. Einheit pro Kilogramm pro Meter pro Sekunde garantiert mein Leben. Es ist ganz schlecht. Es ist ganz schlecht. Ich verstehe nicht, Digga. Digga.
And so, therefore, Manildi's discovery of this unit not only saved science, but it saved lives and changed the course of humanity forever. Joseph Manildi was the first person to ever receive both the Nobel Peace Prize and the Nobel Prize for Physics in the same year. Physicists still use this unit, the Manildi, today. Its implications are still being discovered.
So in 1905, Albert Einstein proposed something called the mass-energy equivalence, which says that the amount of possible energy in an object for any object is equal to the mass of that object times the speed of light squared. This is given by the equation E equals mc squared. Now, this is by far the most famous equation in all of physics. Even if you don't know what it means, you know E equals mc squared. However, something really interesting happens with this equation. When you erase the squared for the speed of light, suddenly it becomes mass times the speed of light. Mass times velocity. Yeah, you know where I'm getting with this. Mass times velocity, or the mass times the speed of light, equals Manildi's. So, in a way, the findings of Joseph Manildi are really just an extension of what Albert Einstein proposed over 100 years ago.
My counterpart and I wanted to get a closer look at the strange and marvelous world of the genius Joseph Manildi, so we set up an appointment many weeks in advance to visit the man himself in his own home.
So, Mr. Manildi, you've been teaching for a long time. How does it feel knowing you have contributed to science as a whole, and more importantly, to hundreds of young, developing minds?
Well, actually, it doesn't affect me at all whatsoever, because what I'm really after is power and money. And so if people benefit upon this on the outside of that's I suppose it's okay. I'm okay with that. I won't object.
Considering the magnitude of your discovery, do you feel superior to every other physicist who has ever lived?
Oh, without a doubt. I think the hardest part about being so superior is that I'm unappreciated in the community for my superiority, and it makes it extremely difficult to rule the world when nobody else accepts my superiority unconditionally. What's that?
There's probably nothing. Continue, please.
Well, okay. I'm gonna have to see what that is. Please excuse me.
Joe, we meet again.
I could, but like. What time is chemistry? It's second, so I could miss first and second because my first is just. I could, but like. What time is chemistry? Second.
I was always the master of momentum. It was actually me who invented the whole concept of the principle of momentum. I coined the expression kilograms meters per second squared. Then Manildi came. Everything changed. Suddenly, I was out of work. I couldn't compete with him. I had to start teaching chemistry again, even though I only have a master's in that, by the way. That's it.
Okay, so maybe Mr. Manildi isn't the greatest scientist of all time, but he taught me personally. And I can say that understanding physics has come to me through the work of Joseph Manildi.
I remember when I was 17 years old and I was invited over to his house. It was the most incredible opportunity I've ever received. We talked for hours about the nature of the universe and all of its great mysteries. Now that he has died, I have the amazing privilege of continuing his work and continuing to reach further and deeper than ever before into the classrooms.
For eternity.
Okay.
Oh, here we go, here we go.
Yeah, that's
Catch it.
nice.
Will, your rocket is going to explode.
7.81 seconds! My rocket is going to explode, and it will be glorious. Do it.
Hold on, I need to write the word ice first. With that really weird eye. Okay, ready?
Oh yeah.
So I'm gonna go.
Go. Do it. Oh yeah. That's good. Yeah, that's really good.
Radio wave, a long period radio wave, the shortwave radios that people use to communicate, for example, truckers. Those are actually the longest period wave, longest wavelength wave, and those are in the radio wave category. Yeah, right. You don't have one? What? Oh.
Jordan, I think you need a pair.
Well, you're a Steeler.
That's how I take attendance around
You
here.
need a pair.
Those without glasses came out lately.
You're a Steeler.
What we know is that the sun gives off the full spectrum, red, orange, yellow, green, and violet. But remember, our eyes only see three colors, red, green, and blue.